Hmm. There we go. Hi, everybody. So I am Katie Herstein, and I'm the Program and Events Manager at Girl Scouts of Colorado. And in my job, I am the one who gets to host this virtual series of Inspiring Futures, where we're introduced to a whole bunch of accomplished women in a variety of professions so you can start thinking about your futures. So we have a wonderful partner that's working with us, and I'm just going to share a little video that we have about Inspiring Futures, and the Girl Scouts are with the CEO of College Invest.
Hi, Girl Scouts. We're here at the Girl Scout Dreamland with Angela Bai. Angela is the CEO of College Invest. I've participated in lots of the Inspiring Futures programs, but my favorite has been the one with people from SeaWorld because I would like to work with animals someday. Lily, what's been your favorite? My favorite Inspiring Futures video was the one about bringing people the light pictures for the circus because I've always wanted to know how lights work or what improves them. Angela, when you were our age, what future film inspired you?
That's a great question, Lily. When I was a young girl, I dreamed of working at the Denver Zoo, and when I turned 30, that dream came true. But what's most important at your age is to see that absolutely anything is possible. And so through Inspiring Futures, presented by College Invest, you get to meet some amazing women. Women who are working with animals, racing cars, catching criminals, helping those in need, and so much more. And so girls,
Let's be inspired.
Thanks. So College Invest is Colorado's college savings program. So basically they exist for one reason, and that's to help save for future payments for schooling after high school. So whether that's college or an apprenticeship program, trade school, excuse me, anywhere across the country. So it's kind of like a piggy bank where, you can put money in, your grandparents' birthday money, anything like that, and it grows in its investments. And then when you take it out to use for your higher education, it's tax-free. So you don't have to pay taxes on that money growing. So it's pretty amazing experience. So I have a daughter who is in her second year at University of Colorado in Boulder, and we have a College Invest savings plan, and it's been very helpful to help pay for her college experience. So, and next up is a bit of housekeeping items. So as you heard, we are recording this session. We put our Inspiring Futures recordings up on our Inspiring Futures YouTube channel so that any Girl Scouts who have missed any of the topics that we've had, or they're just learning about Inspiring Futures and wondering what else we've done, they can go back to our YouTube channel and see recordings from lawyers and pilots, Disney, SeaWorld, Cirque du Soleil, fashion designers, all kinds of different things. So, but let's get started on what we always do at our beginning of our meetings is our Girl Scout promise and law. So you can join me if you'd like, but on my honor, I will try to serve God and my country and help people at all times and to live by the Girl Scout law. And then the Girl Scout law. I will do my best to be honest and fair, friendly and helpful, considerate and caring, courageous and strong, responsible for what I say and do, and to respect myself and others, respect authority, use resources wisely, make the world a better place, and be a sister to every Girl Scout. Awesome. So tonight we have a wonderful evening planned for you to learn all about geoscience. So I am going to stop sharing my screen and introduce you to our guests tonight, and we can take it from here.
Hi, I'm Holly Lindsay. I'm a geoscientist, and my partner in this adventure is Lisa Hall.
Hello.
She is also a geoscientist. I think I will go ahead and try to share my screen and get some slides going, but if anybody has a question anytime, either put it in the chat or interrupt me. I don't do any better speaking interrupted or not interrupted, so just just go for it. So let me share here. Oh, I think, Katie, I am disabled for screen sharing. Can you make it so I can? Because you want to see our cool pictures.
Yeah.
Although I do have a few rocks on my desk I can show off, and I will do so.
I do too, Holly.
I have sparkly rocks. Oh, look at that. That's from Wyoming, isn't it?
I think this one's actually from Morocco.
Oh my gosh.
The
Very cool.
backside has a bunch of really cool quartz crystals on them.
Oh, wow. Do you have any fossils on your desk? I have fossils on mine.
I have shark teeth upstairs.
Oh, nice. See? We're all the same. In fact, Lisa and I have been picking up rocks since we were very small. Okay, I think I can share now, and I can start our slideshow. Here we go. Like we say, this is Lisa Wolf, Holly Lindsay. I'm Holly, and Lisa is my buddy here in turquoise. And we're going to get started. So Lisa, you want to take over?
I will take over. So who am I? It's weird, Holly. I can't see anybody else. I see. Oh, hold on. Let me change something. I want to see everybody.
Okay.
I want gallery. There we go.
Cool.
Okay, so who am I? My name is Lisa. I grew up in Colorado. I always thought that I was actually not going. Oh,
Did the screen share stop?
the screen share just stopped.
Okay, hang on.
Sorry about that. That was my fault. I was trying to spotlight, and for some reason I can't spotlight Lisa. So
Okay.
yeah.
Oh,
Yeah,
you're trying to pin me?
Yeah, and but when I transferred over the host, I think it's Holly that has to pin you because for some reason it's not allowing me to co-host.
There.
All right. We'll see if I can figure that out while Lisa.
Okay. So I grew up in Colorado. I love to go hiking. I love to be outside. I like to be in the garden. I have 2 little kids, and my favorite thing is to have them like all the fun things that I like to do, which is going hiking in the mountains. In the middle picture there, I am looking at something called core, which is where we take a whole cylinder of rock out of the ground. And some of that core is 10,000, 12,000 feet below the ground. So I like to go scuba diving. I love to go fishing. I like to go paddleboarding. I like to go to the drag races. So that's a little bit about me. But I was kind of just a kid that liked to be outside.
Lisa, I love your daughter's t-shirt. Forget princess. I want to be
I want to be the boss.
I love that. Okay, let's go to the next one.
So I started picking up rocks when I was about 3 years old, or so my mom tells me. And I went to community college, and I didn't really know what I wanted to do. I thought I wanted to go into biology. And then I had to memorize a whole bunch of animals, and I decided that was not my cup of tea. So I went to school and got all of my general courses out of the way after high school. I went to Wyoming, the University of Wyoming, and I thought I was going to go into astronomy and physics because I loved the stars. I loved to be outside in the stars. And then I took a geology class, and my class load was so heavy, like I had so many classes that I almost dropped geology. And I called my mom. I was like, I'm going to drop geology. She says, you've been picking up rocks since you were 3 years old. Don't drop geology. Well, I changed my major the next semester, and that's how I kind of got into geology. And I loved being outside. All of my classes were outside. We had to go on field trips outside. So then I went to work in Denver, and then I went back to school and got a master's degree in geology. And then I got to study the San Andreas Fault, which makes big earthquakes in California. So I've worked in California, Colorado, Utah, Wyoming, and New Mexico. So take me to the next one. So when you go to college, you sometimes get to do research in your undergraduate. And I got to go to Costa Rica. Wow. You can unmute and say, wow. Costa Rica was
Wow.
beautiful. I was on a ship, a seismic ship, and seismic is where we set off a sound wave, whether that's from dynamite or a vibroseis machine, or in the water, it's a little air gun that goes off. And that air percussion goes down into the earth and reflects back up, and we can see what the layers in the earth look like from that seismic ship. So I was on the ship for 2 months. And I was, as you can see, the only woman on the ship in the science crew. So out of crew, there were 60 people on the ship. I was one of 2 women on the ship. It was awesome. We got to do some cool stuff. So then after, my friend and she and I got to go explore Costa Rica, and we rode horses into a waterfall and then rode horses back to the hotel we were staying at. So that was really fun. And there's a lot of computer screens on the ship. But yeah, that was undergraduate research is a lot of fun and can take you to some really cool places.
Wow, I'm jealous. That's really neat.
Yeah, I don't think you knew that part, Holly.
I did not. I've known Lisa for a while, but that's some cool stuff. And then
So I did an internship when I was at Wyoming. I did an internship in Denver for a small oil and gas company called Bill Barrett Corporation. And you can see there, I've got 3 monitors there. And those red and black lines on my screen are what you do interpretation on when you're looking for oil and gas below the surface of the earth. The picture above that is a vibroseis truck. When I was talking about seismic and setting off an air percussion or dynamite, there's a vibroseis, there's a plate in between those wheels that sets down on the ground and it shakes. And so it sets off like tiny little earthquakes. And then that's what we record to see what the earth looks like underneath. And then when I was doing my internship, I got to go out to 9 Mile Canyon, which is in Utah, and it is an absolutely gorgeous place to go. And the company I was working for was doing an excellent job of drilling wells there without disturbing very much of the environment around us. So that was my fun internship while I was in college. Oh, it kicked it over.
oh,
So
do
then
you want
I
me
got to
go
do some
back?
really cool research on earthquakes in Southern California when I went to school there in Northridge. So this was for my master's degree. And as you can see on the picture, with all the red lines, those are all faults in Southern California. And that's not even all of them. Southern California has hundreds of faults in it. And there's earthquakes that happen almost daily in California that most of us can't even feel. So one of the cool things that you can do is on the older faults, right where it says Palm Springs. Holly, can you highlight Palm Springs?
Yeah.
That
Circle
part
it
of the
here.
San Andreas fault is where I got to dig this giant trench. And who can see the color difference there in the more reddish rock versus the lighter rock? That is where the San Andreas fault cuts through the earth right there. And you can actually see it separate.
That is so cool.
Wow.
And so in geology, you can study a lot of different things from how the rocks are deposited or laid down to the structures that create the mountains all around us.
Very cool. Wow. That's some pretty neat research.
Who's got questions on earthquakes? Anybody?
It's really neat to see the visual of it and like through that picture, it's pretty wild.
Yeah.
Yeah. And that's a really big hole. I bet you had some heavy equipment to help with that.
We did. We had a excavator and 2 dump trucks to move the dirt off to the side.
Sweet.
And it took us 3 days to dig the hole.
Oh my gosh.
Very cool.
What's my next slide, Holly? I don't remember.
Oh, it's me. It's next.
Oh, okay, good. Okay, good.
But if you can
Um,
stick around, I have some more things about faults and earthquakes
Okay.
in just a little bit.
Yeah.
So who am I? I'm Holly. I have also loved rocks since I was a wee little kid. I have been trying to convince my children to love rocks also, but they have taken different paths. But I love to do things outside. So every one of my pictures here is outside. And basically all these types of adventures started when I was a Girl Scout. I was a Girl Scout from brownies through seniors. Then I was on the board of directors, and I also was a troop leader. So I've always enjoyed helping girls do cool stuff outside and learn new things. And I've always been extremely curious. So being outside, being curious, led me to the path I have taken. But a lot of these pictures are in the mountains and just having adventures, having cool adventures, and my job seems to fit that as well. So what's my background? Like, just like Lisa, I have always loved rocks. I've been picking them up for a long time. In fact, my mom just called me and said, I found another box of rocks. Come home and take care of this. So that is true. I started out at Colorado School of Mines. I've always been interested in the environment and energy, and I thought I would be a physics major and help the earth and help people by helping to generate fusion energy. Well, it turns out that even 30 years later, we're still not really at fusion energy. So it's a good thing that I had a D in that class and they asked me to pick a different major. So I thought, well, I've always loved rocks. I'm going to try geology. So, and that was a good fit. I got a BS in geological engineering at Colorado School of Mines. Went off and had one of the jobs that I'll talk about here in a minute. Came back, got a master's in geology, and it turns out you can often get a good start in your career in sciences with that first degree, the bachelor's, but a lot of us have gone back for more schooling. I worked for oil companies in Texas, Louisiana, and Colorado. I'm also a Colorado native, grew up here, and came back to Colorado. In fact, that's about the time I pivoted to technology. And so now I help make mapping and analytics software. I help all the people that use it and help all the people that write it. But it's still all about rocks because that software is about making maps. So let's go on. What are some of the fun things I've done for work? Well, I got to work on offshore oil rigs and actually arrived at them on a helicopter. And one time I was with a new pilot who couldn't find the right rig. You see, there's a bunch of them out here. And so being a geologist, I knew all about maps. I could pull up the map he had in his helicopter and we found the right rig. So that was a fun and lucky day. No, that was really cool working offshore. And those rigs actually drill holes down. Well, the pipe goes down through the water, and then you drill down in the seabed, and the pipe actually turns a little bit as you go. So one of those rigs can have many different wells going out from it. Another cool thing I got to do was I worked at an open pit uranium mine. And besides mapping where the uranium was and the better rocks were and putting that on a map and telling them where to dig next, I got to actually help blow up the floor of the mine. So we drilled holes all over the floor of the mine, filled it up with primacord and blasting gel. Then you wire it all up. And then just like on the cartoons, you push this little T-shaped thing down and it goes boom. And they let me do that. So the benefit of taking an internship when you're in school was a lot of fun. And I also got to ride in these enormous trucks. They were 75-ton trucks or 125-ton trucks. And just one scoop of rock would fill up the whole bed of the truck. And they let me ride in it. And we drive over to the mill where they turn the rock or harvest the uranium from the rock by concentrating it. And then the bed of the truck would tip back and you'd be worried the truck would fall over, but it never did. So that was another cool job. And
Ollie, to add on to that, if I could,
yes,
the Albert Fry mine up here, the molybdenum mine in Idaho Springs, does a Cha-Cha Truck event. It was last weekend, but it's always in September, and you can go stand and climb in these giant mining trucks.
So here's a question on chat. Where was the mine? The mine that I worked at was actually the world's lowest grade operating uranium mine. So if you're going to work in a uranium mine, you want to be in one that's not super rich, I guess. Anyway, it's in the middle of the Red Desert in Wyoming. And that's another very cool place. The Continental Divide comes up to the Red Desert, just makes a line, and then it makes a loop all the way around that basin, and then it joins up again and keeps going north. So it's an interior drainage basin, and that might have helped concentrate the uranium there. Very cool, a lot of fun. And then in between my bachelor's and master's, I got a job as a park ranger, another lifelong dream, a park ranger that helped people learn about rocks. And I worked at Fossil Butte National Monument. I think it's even a national park now, in southwestern Wyoming. So I learned to fish for trout up there with all my fellow workers. And I also learned about the fossil fish. And in fact, I have them here on my desk that I got a sample.
And that was one of the places we went for field camp in our undergrad, was to go get fish fossils from that area.
Yes, it is very, very cool. And I was so lucky to be a park ranger for that summer. It was a great job. And I actually lived in a trailer area, not real fancy, but all of the other people that were working for the federal government were out there. So I met biologists and I met all sorts of other natural scientists and got to learn some of what they knew. So that was just a wonderful, wonderful experience. So really, really cool. Yeah, that was neat. At the end of the summer, my parents asked me, when are you going to get a real job? And the job was actually ending. So that's when I came back and started my master's. But honestly, all these have been real jobs and a lot of fun. You just never know what you're going to get into. And I mentioned this earlier, but currently I help people do their jobs better. I'm a bit of a manager and a cheerleader, and I just try to help things be more efficient and so that we build what people want and need. Let's get to the next one. So how do you become a geoscientist? Well, a lot of you are in school right now, and you've probably heard the term STEM. It stands for science, technology, engineering, and math. And sometimes they say STEAM, and so they add art to that also. And art is important because it helps you think out of the box. But all those things are the building blocks of what you need to know and do in geoscience. And geoscience is so cool because it brings in all of the sciences. You have to know a little biology. Chemistry is so important in so many different things. Physics is important in many jobs. How do the rocks break? Why do earthquakes happen? So whatever science, tech, or technology or math class you have now, go for it. In fact, at Mines, I wish I'd worked on math a little bit more because I was learning calculus at 8 a.m. and trying to apply it at 9 a.m. in my very first semester over there. So take advantage of what you have. The other thing that geoscientists have, everyone I've met is super curious, and we observe things and wonder about things constantly. And so every time you go outside, you can do that. Ask questions, observe, take pictures, draw pictures. There's all sorts of things that need to be observed and solved. So, and as you heard from Lisa and I, there are many college options that you can choose. So, and almost most colleges have at least some introductory geology courses, if not a whole major. There are a whole set of courses that will get you to that spot. So it's geology or geoscience studies all the physical aspects of the earth, composition, the processes, and it's all about the past and the present and the future. So what is it like? We're going to have a few slides here about some basic geologic concepts. So the earth is a little bit like an avocado. The pit is the core inside, and here we have a picture of the earth and a slice out of it. So you could think of, next time you eat an avocado, think about the earth. The core is solid at the very center, and then very stiff liquid outside that. And then this green stuff, it's a good analogy because some of my favorite rocks from the mantle or the goopy part of the avocado or the somewhat goopy part of the earth are green. Olivine is from the mantle, and it's this beautiful green rock. And then the part that we know all about and we see all the time is the thin skin of the avocado, or we call it the Earth's crust. And pretty much everything we can see and touch has to do with the crust. Probably a lot of you have had a basic science class and you've learned about the rock cycle and the 3 kinds of rock. So I showed this slide to the younger kids last night, and we'll go over it again, but you've heard about igneous rocks. Those are one of the kinds of rocks, and those come from melted rocks or a volcanic eruption. As things get crunched up and eroded and moved, it becomes sediment, and that becomes squished and cemented a little bit, and it becomes a sedimentary rock. After that, if it gets cooked under pressure, it becomes a metamorphic rock. That can get melted again and recycled into a new igneous rock. Well, so that's mostly for the littler kids. You guys might be interested in this. So this is the rock cycle, but this is all of, I don't even know if this is all of the different things that can happen. This is a crazy drawing of all of the different ways that rocks and other things are recycled. This even includes the atmosphere, a volcano blowing out ash and gas. You can have meteorite hit the earth. Water condenses and precipitates out of the air. The water melts things that are in the rocks and moves them through things that are that have porosity. There's faults that move and break things. There's heat and pressure that make all these different kinds of rocks. And then things melt and come back up again. So that's kind of a very complicated picture, but it just shows, to me, it shows all of the possibilities of all the different things that can happen to rocks. Who knows, you may discover other cool things that happen with the natural materials that we have here on the earth. And also it includes the parts that are on that skin, the thin skin of the avocado. The lithosphere is the rocks. The atmosphere is the gaseous part, the air we breathe. Cryosphere is the frozen parts. Hydrosphere is the unfrozen parts of the water. And all of this fits together and helps us figure out how things are happening and what's going on. Well, it's all around us. Geology, every time you look around, either at your desk or outside, there's all sorts of cool things that are going on. This is one of my favorite things, hot bubbling water. this talks to me of geothermal energy, which could be a great energy source for the future, and it's started to be already. Or you just can go out on a hike in the mountains. This is another geologist friend of mine. This is Terry Olson, pointing out some really very cool layers in the rock. Wonder how it got to be that way and what happened here. We'll have a few more what happened here questions later on, but it's always around. Another great thing that I've done and a lot of us have done is learn about the beautiful places we're going. This picture here shows some beautiful ocean or a big lake, and then some layers in the rock. And let's see, there's probably a lighthouse up here. But people that study earth science, we kind of tend to look under the skin. We wonder how it got that way and what happened. Well, it turns out that geoscientists have gone and looked at this, looked at the rocks, and made a map and decided this is what happened. It was a reef. Here's a reef core. There was a slope with crunched up reef stuff off the front of it. Here's a lagoon with other types of creatures on the far side of the reef, and another lagoon over here. And then it says Pleistocene eolianites. What does that mean? Oh, eolianites are like sand dunes. So this had sand dunes for a while. Very cool. What are some of the things geoscientists do? Well, a lot of us just love to be outside and be in the field. So field data collection is often a part of most people's jobs. It might be a smaller part or it might be a larger part, depending. I hope this guy doesn't slip though. It's on a very steep slope. Paleoclimatology, so studying climate in the past and now and for the future. That's another cool job that you could do. And these people are drilling holes in the permafrost, probably up near the edge of Canada, to get information and data there. Here's a picture of some more rangers helping people learn about natural resources and protecting things to be sure people treat them well. This lady is a geochemist. I mentioned earlier that chemistry is a huge part of studying the geosciences. All of the sciences kind of combine in to help us learn about the earth. So it's not just one science. Geological engineers can do anything from figure out where a road should be or if you should build a house here to helping design and drill oil wells. And that the geological engineering that I did was more tilted towards that. But I think these people are having a good time too. Hydrogeology, water is another resource that is hugely important for now and in the future. And these people are getting information and taking data about the water. Well, how can geology help us today? If you guys want to turn on your microphones and pitch in with some questions, I have some starters. We need energy for lights and cars and food. So here's a plug-in car. Here is a power plant making energy. What? Why is an ice cream cone here? Well, turns out you can't get milk to market or make ice cream without energy. Here's a geothermal energy plant. And here's another car. So all the stuff that powers your car, whether it's electric or gasoline, comes from the earth. What things do we use every day that we can't have without geoscience? A sweater? Really? Well, it turns out that my shirt that I have on right now, or some of my hoodies and sweaters, have a chemical in them that we get from oil, polyester. In fact, most of the plastic fibers, the ones that are great for skiing and hiking, those all come from an oil source. Cell phones, without batteries, without glass, without metal, we wouldn't have cell phones. All those things come from the earth, and they come from the efforts of geoscientists that have found these resources. Water, we talked about water just a couple slides ago, but both finding the water and making sure it's good and safe to drink and the container it's in. We can't make those containers without using some oil, and we need our expertise to find good water sources. Does anybody want to turn on their microphone and tell me about something else that maybe we can use the expertise of people that are geoscientists to find?
Salt.
Yes.
It's a mineral, and minerals are like rocks and stuff. So if we didn't have salt, or like it didn't use it, then like a bunch of food would be disgusting. Like potatoes, like mashed potatoes, they need salt or else they just taste plain.
Wonderful. Yes, salt is a feature from the earth and we need it and we've got to have it. In fact, our bodies do not do well without salt. Perfect. Carolyn, you had your hand up. Can you turn on your microphone and tell us what you know?
I just know that almost everything needs at least a bit of energy, either from you or from a machine or from a different person. Like even just wood is needed and needs the energy from the tree to grow and someone to chop it down and someone to cut it into the right shape and a machine to do that.
Mm-hmm. And we need
Anything.
yes, absolutely. Almost everything needs energy. In fact, my coffee cup is made from clay, but we needed energy to mine the clay and we needed energy to bake the clay into a cup. And then I also used some electrical energy, which was made with natural gas, to heat up my water to make my tea. So excellent examples.
How do I say your name, Pratika?
Do we have another?
Yeah, we have another question, another
Cool.
thing to add.
All right. I can go back.
To make jewelry, we like to mine gold and silver, or like
Ooh.
diamonds.
Yes, diamonds and gold and silver, all those things come from mines in the earth. Perfect.
Right? I will show you my ring. This came from a mine in Montana. It's called a Montana sapphire.
Cool.
That's really cool.
Anybody else before we go to the next slide? No?
Cool. All right. So this next
Oh,
slide.
wait. I think Stella had something to
wait.
say.
Okay, cool.
Did you have anything, Stella?
Maybe like something like about like studying like earthquake prevention. I don't really know. Like
Yes. Yeah,
Perfect.
definitely. So you can't prevent earthquakes because the earth is moving and the pressure and the stress that causes. You can never prevent an earthquake, but there is a lot of research being done right now, specifically in California, for an early warning system. So that if the sensors in the ground, the seismometers in the ground feel the earth move, they send out a notice to all of the cell phones within a specific range of that. Yeah, that's excellent.
And I actually have one of those notices right here on my phone. So my son lives in Los Angeles, which is very near where Lisa did her study on that big fault, the San Andreas fault. And my son sent me his phone. They sent out an alert, and I'll read it to you. Emergency alert. Earthquake detected. Drop, cover, hold on, protect yourself, from the USGS. And that came the same time as an emergency alert about a flash flood. Warning is in effect. This is dangerous and life-threatening situation. Do not attempt to travel unless you are fleeing an area subject to flooding. So he said, Mom, I had kind of a tough day. Geologically, yes, you did. In fact, let's talk about some of those other things that the big exciting things that geoscience tries to learn about. This is the a video from space of the volcanic eruption that happened last year in January. Scientists detected some activity there for several weeks prior to it. But there's not monitoring stations really close like there are in Los Angeles, but So it was a little bit of a surprise. And it was one of the giant eruptions that reached 60,000 feet into the top layer of the stratosphere. And it sent a blast wave around the Earth more than 5 times. And there was probably a blast and a submarine landslide. It created an unpredicted tsunami. And they got some notices out that helped people take shelter from the tsunami. And the tsunami is a big wave in the ocean. And they found other evidence of the same kind of eruptions from this earthquake.
We got a chat question. Can
Okay.
underwater volcanoes make islands? And 100%,
Great question.
yes, that is where underwater islands come from.
Yes.
That's how Hawaii was created. And that's also how this Tonga got another new island also.
Yes. That
Great
volcano,
question.
that video that we were watching, it did make another island. So great question. So let's talk a little bit about probability. This is a kind of math, statistics, that you may get a chance to study either now or later. I hope your science and math teachers are starting to introduce this a little bit to you. But Lisa, if you would like to take on this slide, and I can pitch in also. But
Sure.
it's about,
So
yeah, go ahead.
this is exactly what I did, Holly. You just threw me a bone here.
I did.
So in the figure, in the map view, Wrightwood and Pallet Creek and Fraser Mountain are all trenches like I dug on another section of the San Andreas Fault. And what you can see at different locations along the fault, you can then see all the layers in the picture next to it. You can pick out organic material or trees that have burned down or tiny little clumps of charcoal. Think about when you go and have a campfire. Those charcoal that come out of the campfire, you have dated them now of date 0 of when that burn was. And so we can take charcoal from each of those layers and estimate a date for when that layer was deposited. Because generally when these layers were deposited, people weren't having a bunch of campfires. It was generally from forest fires. So you know that if that piece of charcoal is in that sand layer, it's the youngest layer that it could be.
Right.
So that is how you then figure out, well, if that layer below the red line of the fault is cut, but the layer above is not cut, it gives you a constraint on the age of where that earthquake happened. And so this is how we try to figure out how each section of the San Andreas Fault ruptured through time, because you don't just see one earthquake in these trenches, you see 7 or 8 in some of these earthquakes. In my trench, we only saw 4 earthquakes. And so the thought for my project was that we're actually missing some of the fault, or we're missing some of the data, or that section of the fault just doesn't rupture very often. So we can't predict when an earthquake's going to happen, but we have some indicators of when things are going to be more active. Volcanoes tell us a really good story there. Holly, do you know the story of Mount St. Helens?
I do. So fascinating.
Very fascinating. The earthquake activity really picked up before Mount St. Helens blew its top. So that's a really fun volcano to study.
Yeah. And in fact, I am also married to another geoscientist, and we took our honeymoon in Hawaii and went to look at the flowing lava, because of course that was one of the coolest things we could think of doing. So and here's a little blurb about the warning system for earthquakes in California, and it's about a 1-minute warning on your phone, and my son actually got that warning. So exciting and scary at the same time. When we talked about, do you have a plan? Where would you go in your house to be safe? Very, very interesting though.
Go back to
So,
that for a second, Holly.
yes.
So in earthquakes, we talk, in Girl Scouts, I always remember talking about being prepared for everything. And in an
Exactly.
earthquake, you always want to have extra water for yourself, 3
Mhm.
days worth of water for yourself, and enough food that you could get by on a week.
Mhm.
Because what happens in California if there's a big earthquake is that a lot of the roads will be damaged, the railroad lines will be damaged, and it can be pretty catastrophic if you're not prepared.
Yep. And Girl Scouts in Colorado should also be prepared for a lot of things. There's other geologic or weather hazards that could happen. So one thing my son, we talked about that he hadn't done yet was make sure he had several cans of cat food and the cat carriers so he could rescue his cats if he had to evacuate. So here's some more interesting stuff about seismicity. As geoscientists, we're always making maps. We love to make pictures from up above, and this is what it looks like. So here's Colorado. Here's the Colorado-Wyoming border, and here's Wyoming. So the blue stars are seismic events, which are basically earthquakes. And then we have other listening stations along here. And the green ones are ones that the listening stations have picked up. So we're always making maps of that. And then the dark lines are faults, like what Lisa studied out in California.
Stephanie in the chat asked, do you guys have go bags ready? When I lived in California, I had a go bag in my car and in my house. Because I commuted a lot, I drove 65 miles to school. So if an earthquake happened while I was on the road, I needed to be able to take care of myself because the other thing that will go down in a big earthquake is cell phone towers.
That's really good.
And I do have a go bag ready here in Colorado also for a different reason, not because of earthquakes, because our earthquakes are not very big here, but for wildfire.
Mm-hmm.
Because I live in the mountains west of Denver.
So I should probably have a summer go bag. In general, I have my emergency kit in my car for winter. I like to do a lot of winter adventures like backcountry skiing. So I should probably get a little bit more of a go bag in my car for summer also. And I also see another in the chat. This is very cool. I'm listening as I'm looking at my rocks, minerals, crystals, and geodes collection, and I am enjoying this as you put it out on your desk.
Very
Awesome.
cool.
Yes. So you're holding up some. Yeah. So this is great. Lisa, we're not the only people that keep rocks on their desk. Look at all that. Awesome.
Oh, those are great.
I love it.
Yes,
and another
Caroline.
one. Yay.
Rocks are awesome.
They are. Another thing you might have heard a lot about lately is global warming and carbon dioxide. And this is another place where geoscientists can contribute. And there's a lot of information to be had out there, and a lot of good information that you should probably look at both sides or all the sides of a question. So this graph on the left is some information gained from ice cores. So like the core that Lisa talked about earlier, these are a cylinder drilled down into the ice, and then experiments were done on that ice to see how much carbon dioxide was in it. It gets older as it goes deeper, and so we can make a graph of how much carbon dioxide was there at what time. And you can see that, yes, it is increasing here. And the turning point was about when people started burning more things for energy. And in fact, this graph here shows global temperature change. 0 was set to be about 1940. So you can see that. And geologists have discovered there's been massive temperature variations in the past. Unfortunately, humans have evolved to live in a slightly cooler temperature than we're headed for. So we have a problem, and we need to solve that problem. But geoscientists not only can discover the problem and make a graph of it, we can help to figure out what should we do. And in fact, that's why we need, oh, look at these cool rocks that are coming up to the cameras here. We need people that are smart and clever and willing to work hard and think outside the box to solve these problems. There's always going to be a need for people that want to help solve problems. And who knows what you'll end up doing. But this is a picture of some seismic data, like Lisa showed you earlier, with some layers colored in and marked off as places to store carbon dioxide. So we're already starting to work on this, but we need people like you that are clever and wanting to think about how to solve these problems. So here's another picture of that kind of data and what we might do with it. We can't see under the earth, but we can use all this information we get and make maps. And I'm all about cool data because a lot of my job deals with lots and lots of data. So are you concerned about water? Here's a neat picture of using the geology data that we have gotten over the years and looking at the flow of water, how to get enough water for us to drink on the Front Range without stealing too much from the western slope. How do the wells work? How do we recharge our aquifers? The aquifer holds the water that we drink. So you might be wondering a little bit about jobs in geology. Like anything that deals with resources, jobs go up and down, but honestly, if you're interested and passionate about what you do, then you will find work that is useful and fun. So here's some of the things that people do. Geotechnical engineers, we talked about that, building roads and houses, finding resources like what we need for batteries or energy, environmental geology to make sure our environment is clean and things are being taken care of properly. You can work as a professor or a teacher in a school. And this is a very busy slide, but this has a bunch of different areas that people can work in. Carbon capture and storage, erosion, hydropower, studying glaciers, seismology is studying those earthquakes that we talked about earlier, mining, geothermal energy. So you get the idea that there's just this whole constellation of things you can do with science and geology. Before we go on, we're going to do a plug for Girl Scout Day at Dinosaur Ridge. It's on October 14th. Talk to your parents, your caretaker, or your troop leader, and go to Dinosaur Ridge where you can work on badges and other cool things. Here's a great question. We got this question last night. So they want to know, what is your favorite rock, gem, or mineral? Cool. Wow, it's hard to say. I have so many neat things on my desk. And I mentioned a few times, but I might not have shown you this one. This one is all sparkly. And this is a piece of gold ore.
You got to bring it closer. You got to bring it closer. We can't see it that far away.
Okay. How's this?
Put it right in front of your face, though. There you go.
It's hard to see the sparkles. Anyway, this is gold ore that I picked up on a field trip around Leadville. That's another thing that geologists get to do is go on field trips. So we got to hike around and learn all about the rocks. Okay, so we have a little activity stuff here too. Here's some more pictures of some of my rocks. And this leads us into another one of my favorite things about my job. It's being a detective or a sleuth. So we pick up a rock and look at it and we say, what happened here? So anybody have any ideas?
Caroline's got
Yes,
something.
Caroline. Turn on your microphone and let us know.
Okay, it got fossilized. I do have a fossilized shell.
Very
Oh,
cool.
me too. I found one. I was just outside during COVID, and um, I was just outside during COVID looking at rocks in my yard, and I found a fossil. So that was cool.
That is very neat. That's pretty exciting to find a fossil in your yard.
Yeah, Daddy,
This one at the beach.
Auntie Annie's calling.
Rashika, what did go ahead.
Probably
What?
that got fossilized, like maybe like there was mud or something and it got like fossilized in there. So it like left an imprint.
Perfect. Yes, that's a very good lead in. So this rock formed on the bottom of a muddy ocean, and these cool things that you see there, it's not somebody drawing with a crayon or anything, but it's creatures burrowing around in the mud finding food. So this is the Niobrara, and it's shaly limey stone that we see. I found this in a quarry just north of Lyons, Colorado. If you look at this broken edge down here, you can see a lot of these burrows on end. So those are, it's kind of oval shaped, but it got squished when it became a rock. Cool. Good thoughts, guys. Yes, plants also make fossils in there. Okay, we have another what happened here. What do you think? What are these?
Probably shells.
They are probably shells. When I first saw something like this, I thought it was beads that somebody had made, but it's not. You're right, it's shells. So we get a little clue here. This is a different shape. So that might be the skeleton of something. And then you see this, it looks a little bit like a spine and they're still stuck together. Exactly. These are shells, not quite like the one that Caroline's showing us right now. These were more like sea lilies that grew on the bottom of the ocean, and then they had fronds that waved in the water to get food. But I thought this was pretty dramatic that there's so many of them in one place. Yeah, very cool shell. Oh, somebody's favorite is rose quartz. I really like amethyst. That's my birthstone, and that's purple quartz. Okay, I've got one more. We'll see if anybody knows. Any thoughts on this one? What happened here? Caroline, you want to turn on your microphone? I like layers. Yes.
Layers, yeah.
Yeah, you see the layers. But
I
these
think it
layers,
was lava. It was like lava gloop, and then it like hardened when it was still piled on top of each other. Like when you have melted chocolate and it like gloops on top of each other. It kind of
yeah,
fried like that.
yep, very good. I like that. One little boy was watching this last night, and this picture came up, and I said, "What happened here?" He says, "Well, your hat fell off." But another thing that geoscientists often do when we take pictures of rocks is put something else in the picture so we know how big the thing is. So these layers are probably, I don't know, a couple of feet across here, and they're all squidgy here. That's very good. And it probably was different layers, and then it got heated up and got soft, just like chocolate will in the heat, and squished together. Great.
I always like to think about geology as it's a puzzle, but you don't really have the picture. And so you try to put all the pieces together without an actual picture to come up with a story of what happened.
Exactly. To do earth science and geology and geoscientists, you kind of need to be a little bit of a detective and like that sort of thing. It's a puzzle that you have to figure out. I think it's fascinating. Oh, garnet is my birthstone. It looks like a sedimentary rock. So yes, that also is one of my favorites, and some of my favorite jewelry is some garnets. So
Hold
that's
on. Pratika, what do you have?
I went to Moab in Utah and I went to a canyon and I got this rock and you can kind of see the layers in it.
Yeah, that is a sedimentary
Cool.
rock.
Yeah, I have one a little bit like that, and it's probably about the same age.
I
Can you
went
see
to
the layers?
Dinosaur, not Dinosaur Ridge. I have been to Dinosaur Ridge though, but in South Dakota, I went to some like mammoth place. I don't know, I don't remember what it was called, but it's like that big ditch in there, and then they have the building around it, and you can see all the fossils in there. And me and my sister and dad were walking around. My mom decided to go to the gift shop, and she found 65 million year old dirt, which I have. So that's cool.
That
That is
place is so cool. I
Yeah.
went there last year and it's a
so
sinkhole. And what happened was the clay, the whole sinkhole was clay on the outside. And so when the woolly mammoths would come up to drink the water in the lake that was a sinkhole, they would fall in and they couldn't get out because it was too slippery.
What they told me was there was like tar at the bottom, so they went into the river thing and their feet got stuck. So maybe it was like a sinkhole in, and then their feet got stuck in there after the
Yeah.
sinkhole, and they're trying to drink water, and they're like, oh.
That is the biggest concentration of woolly mammoths in the entire United States that we know of.
That is so cool.
It's super cool.
So when I visited my son out in Los Angeles, I got to go to the tar pits. And that's another place where a bunch of creatures fell in a hole and they couldn't get out of the tar. And so there's tons of fossils there. Caroline, what do you have to say? You had your hand up.
I'm not sure what kind of like shell or rock this is.
Boy, I don't know either.
I think it's fossilized coral.
It might be. That's very cool.
Smooth on the back and like bumpy on the other side.
It's
Yeah.
probably smooth where somebody cut it off, but maybe not.
Also,
So-
I have to say, tiger's eye is beautiful because I have a chunk right here, and I just
Ooh.
love it so much because it's so shiny. And it's just beautiful.
It is.
Awesome.
I've
I've
always
heard-
joked that all geologists have a problem called SRS. It's called shiny rock syndrome.
Oh yes.
Yes.
But I've heard this is a tiger's eye, and I'm in love with all of it.
That is beautiful.
They're beautiful.
The other thing that geologists hate to find is the mineral called leverite, which means you pick it up and you leave it right there. We don't do that very often.
I found amethyst.
Ooh,
I
yes,
also found a
love
big
it.
chunk of amethyst.
Beautiful.
Sparkly rocks.
Oh, look at
And,
that.
oh my gosh, Caroline, that is so much.
Yeah, I've got a couple more. I just can't fit them all.
I have a whole empty tissue box full of rocks. Plus 1, 2, 3, at least 3 other boxes of stuff.
I have a whole jar. It's
Rocks are cool.
Rocks are very cool.
Oh, they're rocksome.
Yeah.
I like
I have a
that.
rock tumbler down in my garage, and I have a few of the tumbled rocks here. I had tumbled, I don't know if I had power, but I had tiger's eye, and it was so cool to look at, but it's gone. But I have these 2 filed down pieces. And this one's cool because I don't know if you can tell, but it's my lamp. It's like you can kind of see through it.
Very cool. That's really
It's like
pretty.
a transparent rock, and it's really cool.
Wait.
I was trying to flip my camera around because I'm guessing you guys see that as backwards. But if you don't have one of these, it's a Rocks and Minerals ID guide. And it's got all the pictures in here
I
of
need
different
that.
different minerals and their names. And it's I'm not kidding you, it's really thick and it's really great to have.
Is
I
there a
have
place
this
you like bought that
thing.
from?
Is what?
Is there like a place you bought it from, like a specific place, or can you just get it like on Amazon?
You can get it on Amazon. I bought it from my college bookstore.
Oh.
But
I
yeah, you
have-
can get it anywhere.
I went to like the Larkspur Jellystone thingy, and
Oh,
we had
yeah.
like bags of rocks to like go and try to find rocks. I found this yellow stone, which I still can't figure out what it is, and that was like 3 years ago. And then they also gave us like this whole big guide of rocks and then fossils, and it also says like where they're from and stuff. So that's cool.
That is cool.
It looks like Caroline has a question. Do you want to go next?
Sure. I bleh. I have two tips. There's these really cool rocks called they're called worry stones, and they're like smooth, and you like fidget with them in your hands. And my grandma, and when we went to the National History Museum, no, not history, the Denver National Museum, and my mom and grandma both got like 3 worry stones.
Very
And there's
nice.
just also just a bunch of cool rocks and stuff. There's these really cool like gem trees.
And
Mhm.
I just have something to say. First, when we were doing that mining thing, I found like this arrowhead that was like an ancient arrowhead. So people, when they were like before they had like knives and like guns and stuff, they'd take obsidian. I believe it's obsidian because it looks the same as this thing. And then they filed it down to this certain like shape, and then they tied it next to a stick with like the little grooves in it, and that's what their weapons were. And also, if you can tell how long how long rose quartz and amethyst have been in the sunlight, because the color of rose quartz fades easily in sunlight, and then in amethyst all the color goes away in sunlight. So like, I guess I don't know if that's permanent. Like, I don't know if it's like one of those color change bracelets where you go out of the sun and it's colored, and you go inside and it's white again. But that's cool, and I think that's all I had to say.
Very
With that.
cool.
Very cool.
Yes, Denver Museum of Nature and Science is a great resource. If you hang around there long enough, they'll even let you go in the basement and help the scientists there. I got to do a very neat tour there not too long ago. So yeah, that's a great place. I visit it whenever I can. In fact, when my kids were little, we had a membership there, and they got to take all these cool courses and other neat things. So I hope I've inspired people to work hard in math and enjoy the science. Math is the language of science, and and there's just so many wonderful things to learn about. And always be curious and never quit asking questions, and find the evidence you need to come up with the right answer. Caroline, I'm in advanced math. Good for you. Way to go.
I'm in GT for writing, but it's still good enough.
You bet.
Yep,
Writing
definitely.
is hugely important. People think that you just need science and math to work in these fields. You need to be able to communicate too. You need to be able to get your great ideas and your great solutions out to everybody else.
Yeah,
And we need everybody to solve the problems that we're facing.
Also, lots of obsidian.
You know where obsidian comes from?
Volcanoes. I'm pretty sure it's an igneous, and then it's formed by like magma. And I just love it so much because it's so shiny naturally, and it's amazing. You don't have to wash it 1,000 times, and then it just goes back to being dull, unlike these rocks. Because 90% of my rock collection will be all dull and crusty and musty and dusty. And then I put them in water, and they're shiny and clean for about 5 minutes. And then they go back to being crusty and rusty and dusty. So
thank you all for having us.
Yeah, well, it was wonderful to hear all about it, and to hear you Girl Scouts interacting, and it warms my heart to see how much you love hearing about rocks, and you're seeing your own rock collections. And
yes, I'm so happy that you guys shared shared all your rocks with us.
Yeah, that was so neat. So, yeah, thank you so much, Holly and Lisa. I really appreciate it. And
bet.
Girl Scouts, if you have any other questions that you'd like to ask them, just make sure you have your parent or caregiver email me and I can pass them along.
Me too, Caroline.
And maybe we can get some questions you might have thought of tonight when you're falling asleep going, oh, I should have asked this.
Oh wait,
You can
here's another cool rock.
Yeah.
Must say,
Rocks.
I have at least 10 pieces of pyrite, and that's probably the most. That's
I've
probably
Googled-
the that's probably the rock that I have the most of, because I got this thing for $2 at a garage sale, and it has a bunch of rocks and stuff, and it made me happy. There's my piece of filed down tiger's eye.
Oh,
Oh
That
yeah.
makes me happy that I found it.
all
Yeah,
right.
but anyway.
Well,
Yeah,
thank you
okay.
so much. And girls, do you want to say thank you?
Thank
you.
Thank you
You're
so much.
welcome.
Thank you. Oh yeah, I do have one fun fact. I saw it on Facebook,
Yeah.
but one geode was cut in a way that it looked like Cookie Monster.
Yes, I saw that
I
too.
thought that was like sapphire.
Oh, it was a geode. It is definitely a geode.
Oh yeah, that makes sense though. Oh.
Thank
Yeah,
you, guys.
The closest one I have.
this is just a random geode I got for Christmas, and I was really happy because I got to take a hammer and break it open. So that
That's
made me happy because I
beautiful.
got to smash it. Oh, I have something like that one. I don't know.